Hello and welcome back to Azure Terraformer. Today we're going to be taking the Terraform project that's provisioning a Terraform project to Azure DevOps with fully working Azure DevOps pipelines and a miniature sample Terraform project for Azure. And we're going to be cleaning it up, organizing it, making it support multiple environments, and basically like getting it ready so that we can use it for real. Because last time it was kind of quick and dirty. We demonstrated the functionality, but we didn't quite get it to be enterprise grade. Which enterprise grade is a little bit of a true Scotsman argument, but I think you guys know what I mean. Before we get started, please give a like to this video and consider subscribing. I'm trying to earn you as a subscriber. So if you're enjoying the channel, or if you're new to the channel, consider subscribing. It really helps out. We're trying to get to 1,000 subscribers so I can do some fun stuff like live streaming and interacting with the community and those kind of live type events where we could do live coding together, tackle challenges that you're facing immediately, or just pick my brain in kind of an office hours format. So please consider subscribing. It really helps out. And when you do, make sure you ring that bell so that you are notified when my next video drops. Anyways, let's get started. Let's clean this up. Let's get to automating the automation using Azure DevOps and Terraform. So last time I set up a pipeline and it was quite hacktastic. I have a variable group that I set up, which I removed some of the secret values from, so that I could push my code to my GitHub repo. So you guys can, by the way, you guys can check all my episodes. Every episode, I try and get the source code out on GitHub in a special folder for every episode. So just note the episode number that you're on, and you'll be able to find the source code out in my GitHub repo. If it's not there, send me a little message, a little reminder, because sometimes I forget. But I'm trying to do my best to make sure the source code gets out there. And it's exactly what you see in the episode, without any secrets in it, of course. Because I think that's really important to be able to see the source code, work with the source code. You can take my source code, you can go change it, make it better. When you do, make sure to come back and let me know what you changed. I'd love to hear from you. I'd love to hear what you guys are doing to evolve on the ideas that I'm sharing on my channel. I don't know everything by any stretch of the imagination. So part of this channel, I'm hoping to get feedback from you and learn. Let's clean this up. I've got this variable group here, and it used to have some values in it that I extracted. What I want to do is I want to parameterize this solution so that I can set up n number of environments. Each environment is going to have a different subscription and a different backend. So I need to restructure the variable inputs to my solution here to accommodate for that type of variability. So I think the first thing that I want to do is I want to add a variables file. And in this variables file, the very first thing that I need is the application name. So I'm just going to say variable application name. And I need the environment name. Now, due to the nature of this project, unlike most of the Terraform projects that I set up, this project is automating the automation. And so the Terraform projects that I set up are going to be supporting multiple environments. When I deploy an application, that application is going to have multiple environments: dev, test, prod, stage, load test, perf test, whatever. So it's important that the automation of the automation has support for expanding the number of environments that are deployed. So this environment is not going to be just a string. It's actually going to be a list of string. And I think rather than just calling it environment name, I should call it environments, which kind of implies the plurality of this variable that I'm actually going to be setting up multiple environments. Then what I need is every environment has its own subscription, potentially. I mean, I guess I could copy pasta the subscription if you have multiple environments deployed to the same subscription, but you should really consider setting up multiple subscriptions. So for starters, I'm going to set up a credential for each environment. And in order to do that, I need to create a collection of Azure credentials, one used for each environment. Now, I could use a list of objects, but in this case, I'm going to actually use a map. And because the environment name that I give to the environments is always a very short, completely lowercase string, just to make naming conventions very clean and neat and tidy, I can use that environment name as the key of a map. So instead of a list of environments, I'm going to have a map of objects that represent my environment credential to Azure. So we're going to set this up. It's going to be called variable Azure credentials, and it's going to be a type, and it's going to be a type of map. Now, to declare a type of map that is an object, I need to, inside of here, specify the type. Now, I like to do this on multiple lines, just because it gets really nasty really quickly if you try and do too much on one line. I like to have the open paren and open curly tie up with their corresponding close paren and close curly. That's just me. That's my OCD working. So I've got my object, I've got open curly. Now within this object, this is no surprise. I've got a client secret, it's of type a client ID, it's of type string, client secret. So these are all the things that you need in order to set up an Azure credential. Should be no surprise. I've been doing this on this channel for a long time, and I'm always using these 4 attributes to set up the credentials that my Terraform runs under. So these 4 attributes are going to be repeated for every environment that I want: dev, test, prod, whatever. I guess if it were to happen that I would have 2 environments pointing to the same environment, I could have the same credential copy pasted twice for both dev and prod or whatever. But again, I think best practices, you should keep them separate. Now, the next thing that I need, each environment is going to have a corresponding backend. So this is the storage account where the Terraform state is going to be stored for that environment, which Terraform state can store some pretty sensitive things. So you don't necessarily want your production environment state to be stored in the same place as your dev environment, because the people that operate your dev environment may not or should not have access to your prod environment. So that's why I separate the backend configuration between different environments. So here we're going to have, again, Azure backends. We're going to have the resource group, the storage account, and the container. There we go. So now I have a collection of environment names. I have a map of objects, which is really a collection that's got a key value pair thing going on. A map of Azure credentials, and I have a map of Azure backends. The key for Azure backends and Azure credentials is going to be the environment name: dev, prod, test, whatever. But when I declare the variables, this is how I have to do it. And then the last thing that I want to set up is the URL for my Git repo. So you recall on the last episode, I used a Git repository as a template to set everything up. So I don't want to hard code that in, because I'd like to reuse this in a consistent fashion, no matter what template, no matter what Git repo template no matter what Git repo I use as a template. So I could get nuts. I mean, I could create different Git repos that will deploy .NET apps, that have a fully working CI/CD pipeline for .NET, and deploy the code to an Azure App Service or something like that. I could create an Azure function, pipeline template that will provision the Terraform environment for the Azure function, but then also deploy, compile and deploy the Azure function code. I could also do something with Kubernetes where like I'm building a Docker image and, pushing the image to ACR and all that stuff. So it's really important to me that the Git repo that I use as a template is an input variable for this project so that I can use it in a wide variety of different scenarios. So we're just going to call this the repository. So now that I have my environments variable set, I should probably go and set up my Azure DevOps environments. This is something that I didn't do. Last episode, I kind of relied on the Azure DevOps system to set this up automatically. But there is a resource for an Azure DevOps environment. And again, on the last episode, we used the Azure DevOps environment. We used the Azure DevOps environment as a logical construct. So really, it's just a placeholder name for the resource that we're going to be provisioning. So there's not a lot to this other than the name. Now, because my environments are going to be created based on the collection of environments, I need to set the count meta operator. So I'm going to say count equals length of var.environments, which is a collection. And then I'm going to set the name of the environment to, I'm just going to set the name of the environment to the actual value of the environment at that index. So this is just going to be var environments and then count.index. And so there we go. So now basically I'm going to have n number of environments for the n number of environment names that are in my list of string that I pass into to my input variable under environments. So now might be a good time to set up my variable now might be a good time to set up my TFRs file. So I'm going to set up a Terraform vars file that just has my non-sensitive values. So terraform.tfrs. And inside here, I think it would probably make sense for me just to put in the application name, which is going to be foo, and then I'm going to put in the repository template URL, which is going to be that GitHub URL that I used in the last episode. Now, the other variable that I think I can put in here that really isn't going to change is the environments. So I'm going to set up the environments as an array, which is going to have two values, dev and prod. And because the rest of my environments are all set up in this bimodal fashion, dev and prod, non-prod or prod, I'm just going to continue that trend here. So we're going to have foo dev and foo prod. Those are the two environments that we're going to provision. Now, there are variables that I've declared that I have not yet specified, and that's because those variables contain sensitive information. So in order to do that, I need to set up a hidden TFR file that will not get checked into source code. So I have a convention for that. I call it .debug.tfrs. And inside this file, this is where I'm going to set up the values for the Azure credentials and the Azure backends. And I guess Azure backends really isn't that sensitive, so I could probably get away with putting Azure backends into my terraform.tfrs. But definitely my Azure credentials need to go into this debug TFRs file. So in my debug TFRs file, I'm going to start off by setting the Azure credentials, and it's going to be a map. So when you set up a map, it's going to have a key and a value, always. And the key is typically a string, and the value could be a string, could be any other type. But in this case, I'm using an object. So basically, you've got a dictionary construct. And so here I've got dev, and then I have a dynamic declaration of what the object is in this type. And so if I go back to my variables, I can very quickly copy the structure from the object definition and make sure that I get that get all the attributes set properly here. Now, of course, I'm not declaring the type, so I have to pass a value for that type. So I'm just going to punch that in. And so in the last episode, you saw me set up the dev environment. I'm going to grab the dev application ID. I'm going to grab the dev application ID, client secret, subscription ID, and tenant, which will be the same for prod as well, because I don't have multiple tenants. And I'm just going to punch these in right now. Okay, so I have my Azure credentials set. Now what I'm going to do is I am going to put the backend configuration in as well. It's going to follow the same structure, so I'm just going to copy this and paste this. But instead of being Azure credentials, it's going to be Azure backend. And instead of having this object structure, it's going to have the backend object structure, which is going to be a lot more, it's going to be a lot simpler. And there we go. I've got my backend set. I've got my Azure credentials set. I think I have all the values set that I need, sensitive or not, in my files. Now, I probably need to go and update my debug.sh to pass in this var file. Yeah, it's not debug.sh, it's a TFRs file. There we go. And so there we go. So I've updated my script so that I can execute this. I've got all my input variables. We're all set. But I need to make some changes. So my variable group, which is what's putting in the credentials, I need to go get the right value. So I need to go add a count meta operator to both Azure credentials and Azure backend. And then I need to go access the map using the correct environment name in order to get the correct values out of my input variables and store them into the variable group. So what I'm going to do is I'm just going to first of all add a count meta operator. We're going to set it to the length of environments. And then for each of these values, actually I'm going to add the name just from a usability standpoint. Like we should know like which, because we're going to create multiple variable groups here, one for each environment. So it's going to be kind of important that people know what environment variable group this is. Environments, and then we're going to go count. Okay. And just for cleanliness, I'm gonna make this a little simpler in terms of syntax so that the name of the environment variables follows a clear naming convention. And then in the description, I'm just gonna make it a little bit more human friendly. Okay, and then I'm gonna set these values using the variable. So the Azure credential variable is a map. So in order to access the map, it's kind of like an array, but instead of passing an integer as the index, I'm going to pass in the string value. Now, in order to get the string value, I have to go access my environments array and use an index on that. But this time the index is going to be an integer, which is going to correspond to count.index. And so now that I'm in the correct object in my Azure credentials map, I need to access an attribute off that, which is just going to be client.id. And so I can basically take this and replicate this and just change the property that I'm accessing every single time, and it'll be the same thing. And now I can do the exact same thing for, actually a lot of the work has already been done. The RG Terraform state and TF state, those values, although they are the same every time, because I have input variables for them, they might change. So I should just pipe in the input variables and take whatever values there. So I'm going to use the Azure Backends map, but I'm going to use the same key value, and then I'm going to use a different attribute. So this is going to be the resource group attribute. And now that I've done that and cleaned that up, I can just fix this. And now this is going to be the storage account, and then this is going to be the container. There we go. So now my variable groups are, I'm going to deploy a multitude of variable groups, and one for each environment, and one for Azure credentials, and one for the backend. And I'm just going to take this naming convention and apply it to my backend here, because the same value is going to go in there. But instead of being credentials, it's going to be called backend. And how did I miss a C on credentials? We don't have redentials, we have credentials. And we're going to do the same thing for the human-friendly version of this. There we go. So we have nice human-friendly backends. There we go. So I've set up my variable groups. I've modified them, except the backend. I have not added the count meta operator. That would end badly. You can't reference the count.index meta operator unless the count meta operator is set on the resource block or whatever block you're using. It'll just come back with a validation error. Okay, so variable groups need to change. Pipelines probably need to change as well. Right now they're hard-coded. I'm going to use the same repo no matter what environment I'm in, so I think I'm good there. So let me go clean this up. I do need to use the count meta operator on this. This is not the plan. This is actually the apply. So but I need to have a count meta operator tied to the length of var.environments, because think about it, we're going to have a different deployment. We're going to have a different deployment for every environment. Dev is going to have its own deployer. Prod is going to have its own deployer. And we're going to want to make sure that we, know which one's deploying. So here I can use the var.application name as my folder structure. I promised you I'd clean up the folder structure. And then inside here, I'm going to have a folder for the environment that I'm deploying to. And so this is going to be var.environments. And then we're going to use the count.index to get the correct environment name out of there. And I may have to escape this backslash in order to get it to work. Yeah. Okay. So okay, so that looks good. So now we do have some pipeline variables that get set for each pipeline, which these got to be set. These have to be right as well. We're not going to hard code dev anymore, but we're going to use the environments attribute and then the count.index to pull the right environment name. And then the working directory is always going to be the same. Now, some people set up Terraform projects and they have a folder for each environment in their Terraform repo. I don't like that. I don't like that at all. I prefer to have the same code base manage multiple environments. And so the way I like to set it up is you get a single Terraform project, folder path, which is where your main solution goes. And if you want to target different environments, like I want to experiment with a new feature that I'm rolling out to dev, you can do that by using a feature branch to deploy to dev. But you're going to use the same path. You're going to keep updating the same folder. You're not going to be having a separate, like forked folder structure within your repo to target different environments. Different schools of thought. This is my approach. If you like the folder structure path, let me know in the comments below. I'd love to hear from you. I'd love to hear your arguments as why you like having a separate folder for each environment that you're deploying. But for me, I like having one code base that rules them all, essentially. So there we go. Now, one thing I do need to update is my variable groups are no longer a single item. They're no longer hard coded. So I have to use the count.index because my pipeline is tied by the count to the correct environment. I need to pull the correct variable group using the count index as well. And so because I've tied my variable groups for Azure credentials and Azure backends to the same array of environments, I'm good to go. So now if I go look here, Azure backend, Azure credentials, and this is all set. We have one repo. I think this is probably ready. Let's go check it out. Let's go hit bash. What folder am I in? Let's go hit bash and run our script. So you'll notice I'm running a plan just to see what's going to happen. And looks like we're doing this all from scratch, but we have foo dev pipeline. We have foo prod pipeline. We have the same working directory, but different environment name, same application name. This looks good. We have different environments being created, dev and prod. Of course, I think the environment name should include the application name. So it should say foo dev and foo prod. So I probably need to fix that. I've got my repository being set, and looks like I have my credentials being set. We've got Azure Backend Dev, Azure Backend Prod, Azure Credentials Dev, Azure Credentials Prod. So yeah, I feel pretty good about this. So I feel pretty good about this. Let's run and apply. Auto. Oh no, you know what? So I feel pretty good about this. The only thing I want to change is for the name of the environment. I want to add the application name there. So we're going to go. An internal error occurred. Let's try this again. I'm not quite sure why that happened. And second time apply was successful. The plot thickens. I literally did nothing there. Second time apply was successful. It always makes you feel a little dirty when that happens, but I'll take it. So here's our repo. Let's go look at our pipelines. We have nice pretty folders now, dev and prod with an apply. And if we go look at our pipeline configuration, let's just go see what happens. So we have our backend and we have our credentials, and this looks pretty good. So let's try and deploy this. Let's try and deploy to dev. So I'm going to run this pipeline against main, and we're going to see if we're able to do this. So the plan was successful. However, we have no changes. Do we actually have RG foo dev out there? Did I not destroy that environment? I guess we do. And I didn't destroy the environment from last episode. So I guess it makes sense that we're pointing at the same backend. The resource group is there. So because we're using the same state file, because we're literally using the same storage account, the same key, which is a concatenation of the application name and the environment name, basically Terraform is tricked. Like, this is the same code. There are no changes here, which is kind of the simplistic beauty of how Terraform state works. As long as you point at the correct Terraform state file, you could use radically different code. As long as your code produces the same outcome, you're good. You can do lots of stuff. So in this situation, I am kind of surprised that there was no changes, but that's what we expected. So let's go run the, we actually didn't run the apply yet. Of course, the apply is going to be a big nothing burger because there are no changes. So let's go run the apply anyway. And while we're doing that, let me just go and run our prod environment. And like we thought, foo dev has no changes. Let's go check in on prod. So in prod, we want to create a new prod resource group. Let's go approve this and let's go see what it does. Okay, it was successful. Let's go to our resource groups and see what's there. And there we have it, foo dev and foo prod. And one is in the dev subscription and one is in the prod subscription. Exactly how we want it. Now, here's what's fun. I can go and run destroy and everything in Azure DevOps is going to go away. Everything. But the resource groups in Azure are still going to be there. Why? Because what the pipelines in Azure DevOps did to manipulate state out in Terraform is independent of what we're doing to Azure DevOps right now. Those resources have already been provisioned in Azure. We have not sent a destroy command to those resources out in Azure. What we did was we sent a destroy command to destroy the resources in Azure DevOps. This has updated our local state file, which you can see on my file system here, but it does not change anything about what the pipeline did, which the pipeline that this Azure DevOps project is setting up is actually setting up a Terraform state file in the backend with foo dev and foo prod on the respective storage accounts. Those state files are still there. However, when I ran destroy here, I've obliterated my local state file that was provisioning the Azure DevOps environments. So if I go to Azure DevOps right now, there will be nothing there. There will be no project name project. So if I smash refresh, it's gone. So let me recap. This episode, we took our pipeline and we made it multi-environment. We extracted critical environment input variables so that we could take this Azure DevOps Terraform project and provision a fully working multi-environment pipeline that will actually deploy a dev and prod environment, as we saw, into Azure, using different subscriptions, using different backend storage accounts for state, the works. Now, if we choose to, we could manage our Azure DevOps projects using this approach. And if we wanted to change things in our Azure DevOps projects, we could run Terraform apply and even use Azure DevOps pipelines to run Terraform apply in order to make updates to our Azure DevOps pipelines. However, that's a little bit risky, right? As projects evolve from day zero, when you're like, okay, we're going to build this service, we're going to do this code, you may need to diverge from that template. And so that's where this approach as managing Azure DevOps repositories and pipelines as a long-lived environment may not make sense, because you are very rapidly, due to the nature of Azure DevOps source code, version control management, pipelines, and the software that you actually want to build and deploy, and the environments that you want to build and deploy, you're probably going to diverge pretty rapidly from the template. And so you don't want this this code to accidentally revert all the work that you've done. So for this type of an approach, I think this is really good for situations where you want to have a standard way of deploying projects within your enterprise. Maybe even within your application team, let's say you're building microservices architecture and you have a standard template for a microservice, whether it's deployed to Kubernetes or deployed to Azure Functions or what. Each microservice is probably going to have its own release pipeline that's going to deploy it. It's probably going to have its own repo that's going to have the source code for that microservice. So in these situations, having automation to automate the automation is actually an insane productivity benefit. So I hope you like this video. Definitely more to come. I think the next episode, we're going to set up build verification and some branch protections to implement Git flow to kind of close out this series. But this has been a lot of fun, and you're going to see me use this in future episodes so that I don't have to go manually click around in Azure DevOps anymore. So I hope you like this video. If you did, smash that like button. And if you're new to my channel, please consider subscribing. I'm trying to earn your subscription every week, putting out new content that mashes up Azure and Terraform and other providers as we've done this week, to show the true power of automation on the cloud using Azure and Terraform. So please consider subscribing. And when you do, smash that bell so that you get a notification next time my video drops. Anyways, I hope you enjoyed this. It's great to see you again. This is the Azure Terraformer signing off.